Hello everyone, this is a follow-up from an earlier video after the best fit straight line. Over here I'm going to show you how to calculate the gradient of your graph. Before I proceed on to the gradient, there's something else you have to know, that is how you're going to read the coordinates from the graph. Now, unlike the way you handle kinematics during the kinematics chapter, you're just reading the coordinates. In a practical, you have to do one thing first before you learn how to read the coordinates of a graph. And that is, this is very critical. This is very critical. You need to identify the precision of your scale. The precision of the scale is very important because it's going to affect your final reading. Now, how do you read the precision of the scale? I'm going to zoom in. Right. You have 20, and this is 21. Now, the precision of the scale is read to the half the smallest interval, much like many of your measuring instruments. So half the smallest interval is 20.5. Therefore, the precision of your M1 axis is 0.5 grams. Okay, I'll just leave it at 0.5. Okay, your precision of the M1 axis is 0.5. How about your vertical axis? Let's zoom in and look at this. This is 0.8, this is 0.9. So this should be 0.81. And that leaves this part here to be the half the smallest interval to be 0.805. So half the smallest interval here is actually 0.001. So that means the precision of your D2 over D1 is 0.005. Next, I'm going to find the coordinates to calculate my gradient. And to find my coordinates, I need to draw as large a triangle as I can. So the first coordinate I see is by looking from bottom up, in this direction up. Look for the perfect intersection. And the next one I'm going to see is from top down. And again, look for the other perfect intersection. When I zoom in, I found this to be a perfect intersection. And this coordinate is 21.0, because precision is out to 0.5, so I need to write 21.0, and the D2 over D1 is 0.190. The y-axis D2 over D1 is up to 0.005, so I need to write 0.190. So I'm going to zoom in next to look for the other coordinate, and the perfect intersection I found is here. And this coordinate is 92.0 and 0.820. So x-axis up to 0.5, the y-axis up to 0.05 precision, and that's how I record the coordinates. How about the gradient? Gradient equals, y2 minus y1 over x2 minus x1. So I take 0.820 minus, not enough space, 0.820 minus 0.190 over 92.0 minus 21.0. And you learn from mathematics, we process the numerator and the denominator independently first. Okay, we process them independently first. And we know that 0.820 minus 0.190. So that's 3 decimal place minus 3 decimal place. And my final answer should be 0.630. And therefore, I have to write 0.630. 3 decimal place. And 92.0 minus 21.0. So that's 1 decimal place minus 1 decimal place. I have 71.0. Final answer must be 1 decimal place. Now you look at the value, is 0.630 divided by cell 1.0. So that's 3SF divided by 3SF. 3SF divided by 3SF, my precision must follow according to lower SF, which in this case is still 3SF. So my answer will be 0.008873. I write as 4SF first, and then I convert to 3SF. Because I never know when I need to use the 4SF, right? So I just leave it as it is. For gradient, no unit. I know this no unit divided by grams should be over grams, right? But, well, mathematically, there shouldn't be any unit for gradient. So you leave it as it is, without unit.